All right, pre-AP Algebra 2. Hopefully you guys had a great weekend. We're going to start Unit 2, which is all about linear functions. So we're just going to walk through a quick review of everything you should remember about linear functions from your Algebra 1 and 8th grade math class, okay? And the major thing to remember, right, what makes a function linear, right? And we actually talked about this when we were talking about rates of change in Unit 1, right? That is having a constant rate of change, right? Going up by the same amount, going down by the same amount, right? Traveling at 55 miles per hour, okay? Going to Meijer and buying one bag of potato chips and another bag of potato chips and another bag of potato chips and another bag of potato chips, okay? Or maybe go on a vacation and you're paying $200 a night plus $200 a night plus $200 a night at the hotel room, right? It's that you're having that constant rate of change. So we're just going to go through rule of 4 here and look at different ways that you'll see linear functions. Do a little practice as always. Pretend like you are in class, right? We are going over examples. I know I can't call on you and things like that, but you should be taking notes. You can pause, you can rewind, make sure you're writing everything down. Jot down questions that you have as I probably misspeak or go too quickly through something or don't explain it good enough, and you can ask Miss Moore or myself in class, please. So here goes nothing. Linear functions, okay? So one thing, right, if you think about linear functions, verbal, okay, we've already talked about a couple things. That's that constant rate of change, right? You're talking about about going 60 miles per hour, okay? Distance equals 60 times time, right? Having that constant rate of change, okay? Besides that, most people don't go around talking about constant rate of change, right? There's a key word in miles per hour, which means it's constant rate of change, right? And that is that word per, okay? There's other words that, click like, ooh, that's a constant rate of change. Per is a huge one, right? When you buy gas, it's, I think I paid $1.98 per gallon at Costco, for example, right? That per means it's a rate of change, right? It's happening every single hour, every single day, every single time you do something, okay? So per is a really, really giveaway verbally that we are talking about a linear function and a constant rate of change. And we'll use that a lot in our explanations as well, okay? So we need to look at the equation, right? Hopefully you remember the equation, okay, of a linear function, right? You've probably said it over and over and over. And Algebra 1 is y equals mx plus b, okay? Where obviously m is your slope, which we are going to refer to as your rate of change, obviously, right? And b is your y-intercept, right? B is your y-intercept, right? Your beginning value as you go through that. But obviously, it doesn't have to be written in that order. Actually, a lot of people in some textbooks will write it y equals b plus mx. Because when you're thinking about it, right, you really need to know that beginning amount first. That's where you start, and then you go up or go down from there. So don't be surprised if you see it written that way as well. With that, and obviously we talk about slope is, m, it is your change in y over your change in x. It is your constant rate of change. We actually came up with a formula for this using function notation, if you remember, right? We said it's f of b minus f of a divided by b minus a in terms of function notation. But all those terms mean the same. There's actually a story, I don't know if it's true or not, that why do we use m for slope, right? Those aren't close, all right? It's the story goes that it's m for mountain, all right? Well, the French word for mountain is like montagne. I can't say French very well, but montagne. And the guy that came up with the linear function was French. And if you think about a linear function going up a mountain at a constant angle, a constant rate of change, okay, going up there. So he used the word montagne, begins with M, obviously. So now we use M. Done a little research, not sure if that story is true, but it helps me remember at least. But that's a story at least for why we use M for constant rate of change or a slope of a line. Think about a table, right? You're looking for that same thing in a table, right? How much is it per gallon? What's the price per day? Okay. How much does it cost per, okay, bag of chips? All right. So the equation is showing that over and over and over. Well, a table can show that too with a constant rate of change. You do just need to be careful though, right? Because we're, especially in this class, we're looking at real world data. Some people might look at this, oh, to go from 3 to 5, right? Our change in y is 5. That doesn't show up very well, Mr. Burgess. You're writing blue on blue. Come on. So from 3 to 5, you're going up 5. Well, from, wow, amateur hour. Sorry about that, you guys. How about we are going up 2 from 3 to 5? Sorry about that. Well, from 5 to 11, you're going up 6, and from 11 to 15, you're going up 4. Up, this isn't a linear function. No, it's not changing y, because you might not be collecting data every single minute, every single hour, okay? When you do that, so it's, remember, slope is your change in y, rate of change, okay, as you go. So you got to pay attention to x values too. So here my x value is going up 1, but now my x value is going up 3, and here my x value is going up 2. Well, so what would my rate of change be? It'd actually be 2 divided by 1, or 2. Yep. 6 divided by 3, or 2. And 4 divided by 2, which would be 2. So it does have a constant rate of change. This would be a linear function. So you have to be careful. It's not just my y values going up the same amount. That is not a good explanation for it being a linear function when you do that, right? If you think about it, what really happened here on my table, I skipped 2 and 3 and 5, right? So it would have gone 3 and then 5 and then 7 and then 9 and then 11 and then 13. I skipped those values for whatever reason, all right, with that. So make sure you're just careful of that when you do that. The equation, remember, right? Let's just review how you write the equation of a line, right? Y equals mx plus b. Obviously, we're not using y, right? F of x equals my slope, my rate of change, my constant rate of change, my croc, if you will, right, is 2. We just sort of found that. Okay, x plus my beginning value, right? So the beginning value is not always your first value in your table. It actually happens to be here for this one, right? But it's not like, oh, look at that, there it is, right? Your beginning value, remember, stands for your y-intercept. And we talked about this, I think, in Unit 1, Lesson 2, right? Your y-intercept is always when x equals 0, okay? When x equals 0. So if you look here, you can see our y-intercept right there, okay? It is a point. It is the point 0, 3. So our equation would be f of x equals 2x plus 3. So that's how you can see, that a table, if it's a linear function or not, right? You're looking for that constant rate of change, not necessarily y going up the same amount. And you can easily find the equation, right? If you find the rate of change, the slope, you can then find the y-intercept by finding when x equals 0. Here it's on my table. In a minute here, we'll talk about how to find it when you don't have it just beautifully on the table like that when you do that. So obviously then from a graph, right, you can easily tell if graph is a linear function or not. I'll give you a hint. It's in the shape of a line, right? Hence it's called a linear function, okay? But remember your equation, right? So you have f of x equals, when you're finding slope, you're finding that rate of change, okay? You have your change in y over your change in x. Hopefully you guys remember doing this in your Algebra 1 classes, right? So when you go up 1, 2, 3, 4, right? I'm going over 4. I'm going over 1, 2, and 3, okay? Just remember, it's not 3 over 4. It's change in y over change in x, right? It's your miles per gallon, okay? When you do this, so your slope here, your rate of change would be 4/3. Something I get a lot is, how do you know which point to start at? It doesn't matter, right? As you're going, okay, what matters, you're paying attention to the sign. So if you start here, you can go down 4, and then you're going back 3. So your slope would be -4 divided by -3, which is obviously mathematically equivalent to 4/3. So your equation would be f of x equals 4/3 x, okay, plus b. Obviously, as we just talked about, your b is your y-intercept, right? You got 1, 2, 3, and 4 would be your y-intercept when you do that. And just be careful, right? As we do math, you think about going from left to right. As I go from left to right, I'd be going up the hill, right? Has a constant rate of change. My rate of change is positive. This is an increasing function, right? my rate of change is positive, okay? So that's a good giveaway, right? If your line is going down, obviously your rate of change should be negative. So it's a quick, easy way to double check yourself on that as well. So let's go through finding the equation of a linear function if you're given data, okay? Now, this data is pretty easy to start with because we're just reviewing, obviously. Okay, so the first one we're going to talk about is pretty simple. What if your data, what if you know what your slope or rate of change is, okay, what your croc is, and what if you know your beginning value or y-intercept? So let's say your population starts at 10,000 and increases by 2,000 students per year. So a couple key words to see here is per year. Okay, that's all your dead giveaway. Up, I'm talking about a linear function. That's my constant rate of change there. So P of t equals 2,000. Obviously, notice function notation, P of t, population at a certain time. So I'm going to say 2,000 t plus what's my beginning value, right? So, you know, what are other words that mean begin? Oh, starts, right? So it starts at 10,000. So that would be your y-intercept when you do that. So if you're given the slope and the y-intercept, come out of the equation is pretty easy. Just sort of think about, you know, what information do you have? Those keywords of beginning, start, okay? And obviously per, going up consistently, okay, or down consistently are very, very helpful. So each one will get a little bit harder, but hopefully you guys remember this. Next one, let's find the linear equation if you're given the slope and a point. So we're not given the y-intercept or your beginning value. So the population decreases by 200 students per year, 200 students per year, right? That is my slope. And in 5 years, we'll have 1,000 students, right? So I know in 5 years what it will be, but what was it at the beginning? All right, so when we look at this, P of t equals, obviously we know our rate of change is 200, so that would be 200 t, okay? Our rate of change is 200, plus I am going to write b right here for a second. You can normally just leave it blank, but now I have to find my y-intercept to come up with my linear function. There's a couple ways to do this, okay? I think the best way is the point, first of all, to notice that we were given a point. You're given a value. Right, 200 students in 5 years. That is a point, right? That would be the point 5, comma, excuse me, I said 5, 200. 5 years, you'll have 1,000 students. So in 5 years, you'll have 1,000 students. That is a point. So if you look at my equation here, you'll notice that I have P of t, my y value, that's one variable. T, my input or my x, that's another variable. And I've got b right now, right? That's a letter, that's a variable right now. I've got 3 variables. I can't solve an equation with 3 variables. I can solve an equation and get one solution when I have 1 variable. So the thing to remember then is that this 5 is really your x value, which in this case is your time. And this 1,000 is your y value or output, or in this situation is your P of t. So I'm going to plug those variables in, right? Those values in. And I'll only have one left, b, and I'll be able to solve for that. So if I write 1,000 in for my population equals 200 times time, 5, plus b, I can solve this, right? This would be 1,000 equals, well, 200 times 5 is 1,000 plus b. Okay, and theoretically I could minus 1,000, but I think you guys can probably figure out then that b is 0. So I know then that my y-intercept is 0 for this, okay? My population started at 0. At the beginning, there was 0. Obviously, we do not really need to write plus 0 into an equation, so your equation would just be 200t. Now, I'm going to do this another way. Okay, because a lot of people like thinking about math in terms of a table, okay? And I do too. So hopefully, all right, that works great. I use that a lot. But if you think about this in terms of a table, right, here's your time, here's your P of t, here's your population at a certain time. We know right now that in year 5, we have 1,000 students, okay, at our school. Well, we need to know at the beginning, when time was 0, how many students that we have. So if you think about this, okay, in terms of a table, you need to know what it was at 4, 3, 2, and 1. And you can sort of work your way backwards. Now, sometimes in this problem, you can probably mentally work your way backwards, and that's fine. But here, I'm going to show you mentally working backwards, right? So it's going up. If it's going up 200 per year, if you were in 5 years you had 1,000, well, the year before that you had to have 800, and then you'd have to have 600, and then you'd have to have 400, and then 200, and obviously at the beginning you would have 0. And this is pretty awesome, right? Go math. You can see the y-intercept is 0 at the beginning. And you can actually see my rate of change here is 200, 200, 200, 200. It has a constant rate of change with that. So you can also find the y-intercept by looking at more of a table approach rather than an equation approach. But both get you the same. It's sort of a preference when you do that. All right. So now let's look, okay, if you're given 2 data points. All right. Now, if you think back to the previous problem, we had the slope and a point. Now we have 2 data points. So what do we do, right? So if you think about it, it was pretty easy for us to find the y-intercept once we found the slope. So the first thing we want to do is find slope. So we're going to use these 2 points right here, the 2 data points, and we're going to find slope. Because once we find slope, we are exactly at the previous example, where it's very easy for us to either plug in the point and find the y-intercept or look at a table approach and find the y-intercept. So if you look at this, it says 3 years after opening, the school had 1,500 students. So 3 years, 1,500 students, right? That's a sentence, but that's actually a data point, okay? When you have that, you have an X and a Y, you have an input and an output. And then it also says after 9 years, the school only had 1,200 students. So we're actually losing students. Probably should reevaluate. What are we doing wrong here? But then we know that our rate of change is going to be negative, right? It's going down, 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 down. So I actually have 2 points. So if you think about this one, I have the point 3 and 1,500, okay? And I have the point 9 and 1,200. Those are my 2 data points. Rather, they're just given to you, or you need to read and analyze it. Okay, obviously depends on the situation. So you know how to find rate of change. We did that all last unit in a huge part of Algebra 1, right? Change in y over change in x, y2 minus y1 divided by x2 minus x1, or like we just did, f of b minus f of a divided by b minus a, right? Change in y over change in x. So just to review, if you think about this in terms of, if you're a formula person, right? My slope, my m value would be, and this is the cool thing, it doesn't matter like, oh, what's my first point? What's my second point? It doesn't matter. But if I use 1,500 as my first y value, I have to use 3 as my first x value. Or if you'd rather use 1,200 for your first y value, that's fine. You then have to use 9 for your first x value. Okay, you got to keep them together. All right, they are an, that's right, they are an ordered pair, right? You got to keep them together. So I am going to go 1,200 minus my other y value, which is 1,500. And this is what I'm talking about. Since I used 1,200 first for my y value, I'm going to have to use 9 for my first x value minus 3, which would give me 1,200 minus 1,500, okay, would be negative 300 divided by 6. So my constant rate of change, my slope, my montagne would be negative 50. That's not very good French. I feel like I just turned Italian. That was pretty bad. All right, I need to work on that. So your slope is negative 50 there when you do that. But wait, okay, some people, okay, like thinking about this, okay, if you didn't get a chance, right, make sure you're pausing this and writing important things down. Some people like to think about this in terms of a table. And if you look at those points, it really already is a table, all right, when you do this. So if you make a table here of t and p of t, you have 3 and 1,500 and 9 and 1,200. And if you think about this in terms of a table, my change in time, or x, is 6. My change in y is negative 300. Sorry, I went a little bit off the screen there. And so negative 300 change in y over change in x would be negative 50. Look at that. Okay, so either way, whatever your preference is, some people really like formulas, some think more of a data perspective, okay, like the table version. Either way, your slope is negative 50, or your rate of change. And now obviously we're going to quickly just find my y-intercept, okay, to do this. So I've got P of t equals negative 50t plus, now I have to find the number of students when I do that. So I'm going to do a table. I sort of like doing a table, but you can obviously plug in a point to do that. If I work backwards and I want to find it at the beginning, right, I would have to go from 3 years, 2 years, 1 year, and then 0. So at 2 years, I would have, remember, I'm losing 50 students a year. So I would have to have had 1,550. 1 year, I would have to have 1,600. And at year 0, I would have to have 1,650 because remember, I was losing 50 students a year. Okay, I was losing 50 students a year. So my y-intercept is 1,650. Okay, you could just as easily, I'm going to erase all of this, you could just as easily plug in a point here and find the y-intercept for those of you. Now I've got 2 points, but they're both on the same line. It doesn't matter which points you choose because they both make the equation true. Okay, let's pretend that we don't, whoopsie, let's pretend like we don't know the y-intercept here. Okay, I can plug in either of these points. I'm going to choose 9 and 1,200. So I would have had 1,200 as my y value equals negative 500. And my t, my time, my input is 9 plus b. So this would be 1,200 equals negative 50 times 9, right? 9 times 5 is 45. So it'd be negative 450 plus b. And then I would obviously add 450 to both sides of my equation here. And my y-intercept would be 1,650. So you can see that it works either way, whatever your preference is when you do that, okay? And so last but not least, okay? All right, that's all Algebra 1 review. We're going to be really big picky. Okay, great, you can memorize a formula, but do you know what it means? So you're going to constantly hear Miss Moore and myself saying, interpret. What does it mean? Great, you found a number. Whoop-de-doo. If you don't know what it means, it's worthless. So we're going to really ask you on everything you do to make sure you interpret both your slope and your y-intercept, okay? So the key thing here, and we're going to work on this a lot in class, your slope, remember, is a rate of change, okay? So you got to use words that mean change. So this is like increase and decrease, okay? But it depends on the situation, what word you use. And obviously, it's a rate of change. There's a y and an x. So for example, my slope here is 35, okay? So it's P of t. So I'm talking about, I'm just not going to say my slope is 35. That's not telling me anything, right? I'm using P of t. I'm talking about population at a certain time, all right, how much it's going up. So I would say, for example, my population is increasing 35 students. Now that still doesn't cut it. It's increasing 35 students. Well, that's my change in y. That's my output. What's my time? Am I increasing 35 students every day, every year, every century? It totally depends, okay? Every single hour. That's going to be a pretty full classroom. I don't mean Mrs. Moore are good teachers, but we don't want to grade our whole entire life just for one class, right? So, and we'd run out of desks and space. We'd probably have some issues there, right? So it's a rate of change, right? It's increasing 35 students, that key word, right? Per year or per month or whatever it happen to be talking about, okay? A lot of times people might think, I think per works great, but a lot of people may use like for each, for every, things like that. That can mean the same thing, but per is the most common word to show that it's a rate of change when you do that, all right? So obviously 55, right? You've got t and you've got d of t, all right? So if you think about that, all right, obviously that's positive, so it would be increasing, but it would not be increasing 35, right? It'd be increasing 55, right? Students don't make any sense, right? I'm talking about d of t, so probably talking about distance. So maybe I'm talking about miles, okay? But once again, that's not a rate of change. Hey, I went 55 miles. in a year, in an hour, in a month, what's going on, okay? When you're doing that, how fast did you drive? You know, your parents are asking how fast you drive. 55 miles. What do you mean? Right? 55 miles per hour. Great. You're going the speed limit. Maybe you should say that and be like, I was going 55 miles, but don't give them that. Right? If you're going 110 miles, which you should never, ever, 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 ever do, right? So you can be like, I was going 55 miles every half hour. What? You're going 110 miles per hour, right? So that change in X, that time is very, very important. So this would be 55 miles per hour. Make sure you guys are being nice, safe drivers out there when you do that. Okay, so now let's talk about interpreting your slope. All right, like I said, we just don't want to say like our y-intercept, excuse me. You just want to say like our y-intercept is 70 or 700, excuse me. What 700 what? Right, 700 what? So obviously here we're talking about population. Okay, so we would say, well, you can't just say 700 students. What do you mean 700 students when, right? Remember the y-intercept is a point, right? It's 0, 700. So when you are interpreting that, you got to make sure you're talking about both the x and the y, okay? About both the input and the output when you do that, right? So your x and your f of x. Now don't say, right? You could say when time was 0, there was 700 students, but I don't know anybody that talks that way, right? That doesn't really show us that you understand, right? That just shows you that you memorize something, right? So how do you say that, you know, what your y-intercept when time is 0, right? Yeah, you'd say at the beginning. So you'd say something like at the beginning, there was 700 students, okay? When it first began, when my school opened up, okay? Things like that, there are 700 students. So you got to make sure you talk about both the input and the output when you do that. All right, so hopefully you guys enjoyed this video. I'm sorry, I'm sure it was not good as Mrs. Moore's per usual, but hopefully you guys learned some stuff. Like I said, please rewind this, please rewatch it, make sure you took notes, and then bring those questions that you have to class and we can discuss. All right, thanks everybody. Have a great day.